Hey, so this video is to talk about the SSA ambiguous case. Ambiguous case. So it's where I give you an angle, like angle A here, and I give you two side lengths, sides B and A, but it's not something that guarantees only one type of triangle. It sort of depends on the info you're given. So the one thing you can determine, if you put the unknown side on the bottom here, you can just assume it's however long it needs to be. Excuse me. You can always figure out, since angle A is locked in, this side's locked in, side B. You can always figure out just from that what the height of the triangle has to be. So if we use sine of angle A has to be the opposite side, h, the height, over the hypotenuse, which is B. And so B sine A equals the height. And since we know what little b is and capital A is, then we can always figure out what the height is. So let's assume that we know the height in addition to angle A, and little b. Excuse me. All right. So what I want to do is look at the different scenarios we might get here. So right here, I have that same kind of picture. And here's what we'll do. Whoops. Sorry, hold on. There we go. Okay, so if A is small, so it's only this big, right? Or even smaller. You can make it smaller or bigger here. If A is small, then there's just no way I can connect it to this third side down here to make a triangle. So if A is anything that's tiny, there's just no triangles that are going to exist. In fact, the very first time you can get a triangle is if A was just long enough so that you could drop it straight down. And in that case, it would have to be the height of the triangle. And then I could just swing it around where it just grazes right there. That's the only place that I could actually connect the thing to make a triangle. And it would be a right triangle then. So over here, I'm going to write out our scenarios. If A is small, in other words, if A is less than the height, then no triangles exist. And if A equaled the height, then we get one triangle. Just one triangle. Let's say exactly one triangle. And in that case, it's going to be a right triangle because A is the height. Okay, so let's come back over here and see what happens. What if it's a little bit longer than the height? So right there, it's A is the height. And now A is a little bit longer than the height. You can definitely connect it over on this side. Let me make it a little bit shorter. Yeah, we can definitely connect it on this side. And I could also swing it around and make a different triangle right here where there's A, there's B, and there's the third side in that case. Okay, so I could make one on this side, or I could make one on that side. And that's true for A up to, if it's longer than H, and up to B units long. Because if it's B units long, then I actually can't swing it around over here anymore because the only place it's going to land is right on top of the other B. But I could swing it over here. So if it's a little less than B, I can connect it on this side or on that side of the height. But if it's equal to B, I can only connect it on this side. Right? Because if I swing it over, then it just fits right on top of that, and I just get this angle here instead of a triangle. Ooh, okay. So let's write that out. If A is bigger than the height, but less than B, then two triangles exist. And if A equals B, then exactly one triangle exists. And in that case, since A and B are the same, that'd be like this. That's got to be an isosceles triangle. Okay, and coming back over here, what if A is a lot longer than B, or just anything longer than B, right? Well, I can't swing it over here at all, because that's not going to form a triangle with those solid lines. But I can definitely connect it over here. So there's one triangle that exists if A is longer than B. So over here, if A is greater than B, then exactly one triangle exists. And if you wanted to, you could basically combine these three cases. If A equals H or is greater than or equal to B, then one triangle exists. Okay, now this is a special case. This is the case if angle A is acute. So let's look at what happens if angle A is right and if angle A is obtuse. So going back over here, if angle A is a right angle, so this angle here, that's got to be a right angle. Let me just move this over. First, let's shrink A back down. So now B and the height are the same thing, right? So I'm just going to fit that right on top. It looks like BH. So B and the height are the same. Okay, if A is too short, well, there's nothing I can do with it to make a triangle, right? I could lengthen it a bit. It's still shorter than the height, or B. Still can't form a triangle. First time I can even connect it to this third side is if A and H are the same length, or A and B. Whoop. All right, let's go this way. There. Now it's the same length, but I can... Ooh. But I still can't form a triangle with that when they're equal. I can only form a triangle if A is longer than B right here. So if A is less than B or equal to B, no triangles. If A is greater than B, you can tell over here, you can only form the triangle on the one side. If I come over here, there's, that zigzag shape but no triangle. So it's got to be over here. Exactly one triangle. And then the same sort of thing happens if I make angle A an obtuse angle. So right now, little a is less than little b, and I just can't connect it to this side to make a triangle. If I make it equal to b, let's see, equal to b, I still can't connect it to this third side to make a triangle. The best I can do is have it latch on at angle A right there. So still A equals B, no triangle. If A is bigger than B, I can connect it on this side, can't connect it on that side. And if it's way bigger than B, well, same deal. You can kind of tell, oh, I can connect it over here, but if I try to swing it around, I'm not going to get a triangle at all. So here's for a right triangle, and it turns out for an obtuse triangle, it's the same exact thing. Okay, so there's all the main info for given angle A, side B, and side A. Okay, hope that helps.